Guys, we have a problem. A bomb has deposited in the sewage. We will need to build a robot to navigate through the tunnel to defuse the bomb. So, Ziyun, Ding Chen, and Qi Yong, you all will form the Untitled team to build the robot. Understand?
Yes, sir!
Winston, Qi Yong, you will be assisting me to do the algorithm. Understand?
Yes, sir! Yes, sir!
Listen, you'll be in charge of the remote control for the robot. Understand?
Yes, sir!
Solin, you'll be in charge of doing the commission for the R5. Understand?
Yes, sir!
As you all can see on the left, this is the overall architecture for our robot system. The Android start button will send the sub command to the PC, after which PC will send the movement command to the Arduino, in which is relayed by the Raspberry Pi via Wi-Fi.
Hi, I'm Qi Yong.
I'm Qing Yong.
And I'm Winston.
And
we are the algorithm team!
Hi, I am Qing Yong and I'm in charge of the simulator, where it traverses the robot for the shortest path and acceleration algorithm. I'm also in charge of designing the simulator to let it have a stick loop and implementing the necessary for the checklist.
For the exploration, we use right ball follower with flash algorithm, which sets the robot to move to the nearest wall. Then the robot will move around the arena in an anti-clockwise direction. The robot keeps obstacles on its right side and keeps track of all its turns using a counter. It will prevent infinite loop problem due to the isolated island problem or incorrect sensor reading.
Okay, the algorithm our group has decided to adopt is the A-star algorithm for the fastest path. Now, the reason why you want to use the A-star algorithm is because it's able to compute a path with the least number of costs. So, in our group's definition, the least number of costs means traveling the least number of tiles as well as having the least number of turns. So, as our robot is only able to turn in 4 directions, we use the Euclidean distance to compute the heuristic cost. As you can see, our robot is able to use the A-star algorithm to actually travel in its fastest path to the goal.
Hi, I'm Qi Yong.
I'm Ding Chen.
I'm Ziyun.
We are
Untitled team!
We install 6 short-range IR sensors, 3 in the front, 2 on the right side, 1 on the left side. Due to the weight of our robot, the front side sensors are tilted to accurately detect first 3 blocks, and the right 2 sensors are used to calibrate using the wall.
Since the robot movements are inconsistent, we decide to implement a calibration function to our robot. The calibration function is to ensure that the robot is in its correct position. And this will be our front calibration, and this will be the side calibration.
Our robot consists of 2 motors with encoder. We attach PID and use encoder feedback to let our robot move straight and turn in, as you can see from the video here.
Hi, my name is Solin, and I'm in charge of the Raspberry Pi. The Raspberry Pi is in charge of the communications of the data between the PC and then the Arduino board. Raspberry Pi will first wait for the data from the PC via the TCP socket. Once the data is received, then I will pass the data to the Arduino via the serial port. Once that is done, it will wait for the response back from the Arduino board via the serial port. Then, it will just send it back to the PC via the TCP port.
Hi, I'm Jason and I'm the team lead of the Android team. I'm in charge of developing the application which will be used to control the robot during its operation and also to display the surrounding environment of the maze during exploration.
Three, two, one, go. Hey!